Hello IT Pros, welcome back to my IT workshop. So in this video we're going to continue doing one more example about subnetting based on number of networks, and then we're going to do reverse engineering to an IPv4 address. So if you haven't watched the previous videos, you can find them in the top right of this screen. So without further ado, we're going to proceed with our last example. So I'm going to choose a class A 10.0.0.0 that we have done, I believe, in the second video or third. And for this, this is a really big network that we're going to do. Well, not networks. So we need 998 networks, which is a lot. So you might not need this many in any corporation at the same time. So for practicing, this is really good. So we have our graphic here, and we proceed to the first step: convert 998 to binary. So this is going to be 11111100. 110, which are going to be 10 bits. So you can tell it's going to be a lot of networks. Now we proceed to the second step, convert the default subnetwork mask to binary, identify the networks and host portions. So the default network mask for a class A is 255.0.0.0 or /8. If we convert this to binary, we are going to have the first octet filled with ones, and the rest is going to be zeros. As always, we're going to underline the network portion and the host portion. Our next step is what are we doing? Are we creating more networks or allocating hosts? Well, we are creating more networks, so we have to reserve these 10 bits in the network portion. So I copy the default network mask, and now I'm going to, for a class A, and now I'm going to reserve the ones, the bits, 10 bits, starting from left to right. Don't forget, the network portion is represented by ones. In this case, I don't have any more space in the second octet, so I have to go to the next one to complete my 10 bits. So, and the rest, I'm going to complete it with zeros. Okay, we have it completed with zeros, and now we can find our new network mask, which is going to be 255.255.192.0 or /18. Now we're going to find our increment, which is the last one of our reservation. If we look from left to right and from right to left, the first one after the zeros. So in this case, my increment is going to be 64. For the third step, we are going to define our network ranges. So I'll copy the network 10.0.0.0 and check that the change is happening in the third octet. So for the next is going to be 64, again in the third octet. We continue from there. Then we have 128. If we add 64 to that one, I'm going to have 192. If I add 64 to 192, I'm going to have 256, which is more than 255, our limit. So what happens when this case comes to place? Well, we go to the next octet, which is going to be the second, and that becomes 1. So 10.1.0.0, and we continue on with the increment. So the next one is going to be 10.1.64.0. The next one is going to be 10.1.128.0, and so on. We can continue doing the networks, which are going to be a lot. So we have our network IDs on the left side, and now we're going to find our usable IP addresses. The first one we're going to have from 0.1 to 127.254. The next one from 64.1 to 127, also 254. And we continue filling all our ranges. And the next thing we're going to do is we are going to, well, as you can see here, when we change the digit in the second octet, we continue doing the same. So as we have done before, don't worry about it. You always have to go to the previous octet. Now that we have all our ranges here, we are going to, as always, calculate how many hosts we are going to have per network. So we go to our identity, or not identity, to our 2 to the power of 14, because those are the host portion. We have 14 zeros after our reservation, minus 2. So that's going to be a really big number, 16,384 minus 2. We are going to have 16,382. So that's a really, that's a lot of usable IP address per network. So this is just an example. You may never need this many hosts in the same network at the same time. Okay, so we continue now to calculate how many networks we are going to have with the 10 bits we have found in the first step. So 2 to the power of 10 is going to be 1024. So we have 1024 networks that we can find. So we can continue. The next one would be 10.1.192.0 and so on and so forth. So now we're going to proceed with reverse engineering. The main point of the reverse engineering is that starting from the result, from the final product, we go back and try to find out how this was done. So that's what we are going to try with IPs, IPv4. And in this case, we are going to have our small home network. This can work for any size, any network size, corporate or anything. We have a router, which is also our gateway. We have a desktop computer that is connected with a cable. We have a printer, which is wireless, a tablet, and a PS4. Well, I believe that's PS4. So what we have in this example, we are given the IP addresses that each of these devices have, and the mask. In this case, it's going to be 27. As you can see, I'm filling out the IP addresses. And this is the kind of question you're going to find in certification exams, like Cisco CCNA or the CompTIA Network Plus or any other. What they are going to, they are going to ask you is, what is wrong with this scenario, because the scenario here is that the computers cannot connect to the internet. They cannot reach outside of this network or even connect to any other device in the network. So what we are going to do now is we have some clues. I know this is a class C. I can check it because it's 192.168. And the next clue I have is that they give us is the network mask, which is 27. Okay, so those are our two clues that we have in this case. And what we are going to do, since we have the network mask, is that we're going to convert it into binary. Okay, so we have 27 bits and the rest is going to be zeros. So this is, if you remember, this is the second step in our 3 steps procedure, whether it's for network or host. And as always, we can find our increment since we have our network mask. And the increment in this case is going to be 32, right? And since I have the increment, I can calculate the network ranges. So as you can see, this is this is way faster than doing the whole process because we have more information now. So I have, it's a safe bet to start in 0, because every network or subnetwork is going to come to 0 at some point. So our increment is 32. So I go 32, 64, 96, and the next one is going to be 128, and so on and so forth. The next is going to be 160. But wait, I don't need to go further because I have found my network is 192.168.21.120. Why? Because all my networks, all the IPs that I have in this example have a number around this IP or this network ID. So I have the ranges from 21.129 to 21.158. And now I'm going to compare it with the IPs I have here. So if I compare it with the first one, I can see that 21.128 is my network ID. And of course, I cannot use my network ID. The broadcast and the network ID cannot be used by any device. So this is the problem with the gateway IP address. But the gateway IP address is actually my door to the internet or to other networks. So if I fix it, will it work? So let's go to the printer IP. So it's 159. And 159, as we can see, would be the broadcast address for this network, because the last usable IP address is going to be 158. So it doesn't work either. So the next one is going to be 21.126. And that one is a valid IP address. However, is the last usable IP address for the last network before 128. So for 21.96 is the last usable IP address. So that's a problem. We cannot use that one because it's in another network. Is it a valid IP? But it's in another network, so we cannot use it. We go to the tablet, which is 21.130. That one falls in our range. So that one is the one that is correct in this case. So we can use this IP address. This is totally correct. And now we proceed to the next one, to the PS4, which is 21.160. And that one is not a valid IP address since is the network ID of my next network. So after 128, we have 160. So that one is my network ID. So we cannot use that one as well. Well, we cannot use that one either. Well, technically that's what reverse engineering. I wanted to do a big example. So you can have different masks, you can have different classes or requirements, but they are going to give you the mask at least, and there are a few IP addresses, and that's technically all you need to know about reverse engineering. So you have some information and you go back. Okay, don't forget, if you have the network, the subnetwork mask, you can find the increment with no problem. So that would be for this video, guys. Thank you for watching. If you have any question, leave it in the comment question below. If you like this video, please leave a like. If you haven't yet subscribed to the channel, I encourage you to do so. And thank you for watching. The next video is going to be a real example for a real network. I'm going to design a real network. So thank you for watching again, and I'll see you in the next one.